Welcome back. We're still on chapter 3. We're on page 90. If you have your book, go ahead and turn to page 90. If you don't have a book yet, it's Amazon, Preparing for Algebra. My name is Susan Everingham. Okay, so we're talking about fractions here, and it's just a very simple introduction. 1/4. 1 is the numerator, 4 is the denominator. It is 1/4 of a whole. And in the case of the circle graph below, you can see that the one part is shaded, that's the numerator, and the whole total is 4. So it's 1 out of 4 parts are shaded. So go ahead and come up with the fraction for the 3 circles below. And we'll go on to page 91. Hi, okay, page 91. This is an introduction to fractions. And what I want you to do is write out each fraction. So we learned that 1/2 is written 1/2. It's important to learn that numbers can be written in so many different ways, and this is just one of them. It's part of word problems, so this is why we're starting here. We're going to be continuing with fractions throughout the entire book because it is the backbone to algebra. Okay, so go ahead and write out all these fractions, and I'll see you on page 92. Page 92. Now we're immediately getting into renaming fractions. Renaming is used to find an equivalent or to simplify. The process keeps the fraction always mathematically equivalent. For example, we can change 3/4 into 6/8 by simply multiplying 2 over 2. They both end up equaling 75% or 0.75, right? You can see the circle graph here is 3 parts shaded to the 4 parts altogether. The first example is 2/3 equals something over 9. How can we change 3 into 9? Well, we're going to multiply 3 on both the numerator and the denominator, giving us 6/9. So 2/3 equals 6/9. If you can't visualize these numbers in your head, do draw circle diagrams and then shade the parts appropriately. You'll see it very clearly. Okay, so I want you to rename each of these fractions. Let's look at 3/4 equals something over 12. So 4 times what number is 12? And you do the same thing with the 3. So 3 times 3 is 9. 4 times 3 is 12. We're going to get into the meaning behind 3 divided by 3 in a minute, and how important that number 1 is. Page 93, simplest form. So to find the simplest form of a fraction, we're going to find the greatest common factors of both the numerator and the denominator. And then when we divide the numerator and denominator by that factor, you will get the simplest form of that fraction, right? This is where all that GCF stuff is going to pay off. The example here is 14 over 48. The greatest common factor of 14 and 48 is 2. So we're going to divide 14 by 2 and 48 by 2, giving you 7/24. Dividing by 2 renames this fraction 7/24, but it does not change its equivalency. It's just a simple form. We know we also have gotten down to the simplest form because we have a prime number, 7, in that number. We'll get to primes soon anyway. And remember that when we are reducing, we're just renaming them. We're just calling them something else, but we have not changed the value of the number. Go ahead and simplify these 3 fractions. I'll see you on page 84. Hey, so we're on page 94, not 84, right? We're on to reciprocals. Beginnings of reciprocals is a way of changing a number 2/3, multiplying it by its inverse 3/2 to equal 1. So it's just basic multiplicative inverse. saying large words for me is often not so easy. Okay, multiplicative inverse, and these are part of proofs too, that eventually you get into geometry, but reciprocals are super important. It allows you to isolate things. In our world of algebra will be variables, but let's just learn reciprocals right now. So in this case, I said 2/3. The reciprocal is 3/2. And when you multiply them, it gives you number 1. So 2 times 3 is 6. 3 times 2 is 6. 6 over 6 is 1. So any number over itself equals 1. 1 whole. So we go back to fractions. Remember, 6 shaded parts of 6 areas to shade. So all 6 in this case are shaded. So meaning 6 out of 6 is 1 whole, right? That's the idea of it. So the reciprocal of 3/5 is what? 5/3. And to multiply 3/5 times 5/3 will give you 1. All right, go ahead and finish the reciprocals. There's a couple here that represent whole numbers. For example, 7 over 1, and that's what the blank is. So what is its reciprocal? I'm going to leave you there. All right, good luck, and we'll see you on the next page. Great. Welcome back to page 95. So 95 is mixed numbers into improper fractions, okay? And there's a process. The process is that you take the denominator, you multiply it by the whole number, and then you add the numerator. In the case of the example, 2 1/4, we've got the denominator 4 times 2 plus 1. Gives you 9/4. Right? So there are 9 pieces of pizza out of 3 pies. And as you can see in the visual here. Think about the relationships between fractions and whole numbers. Like on the previous page, I put a 7 numerator over something. 7 over 1 is 7, but it is also a fraction. It's 7 whole pieces, right? In this example, we've got 4 out of 4 because our pie is all cut up into 4 pieces. So we got all 4 shaded in 4, making it a whole, as we talked about. Please rewrite the mixed numbers here and put them into improper fractions. So 2 5/8, again, denominator 8 times 2, the whole number, plus 5. And go ahead and figure those out. At the bottom, I want you to draw circle diagrams, like we have up here, of the answer. So 3 1/4, knowing that the denominator is going to be 4, so all your pies are cut up into 4. So you're going to have 3 whole pies shaded, plus 1/4 of a 4th pie shaded. All right, give you an idea there. We'll see you on page 96. Bye. Awesome. Page 96, we're going to be comparing fractions. Some fractions are pretty easy to compare. All we need to do is to have the same denominator. And in the case of the first example, 7 over 10 and 3 over 5. Which one's bigger, smaller, or are they equal? So what we want to do here with these simple ones, if there's the LCM, which is 10, then we can go 3 times 2 and 5 times 2, just creating a 6/10 equivalent fraction for 6/10. Which one's bigger? 7's bigger than 6. So this one is pretty easy to go. It's when we get numbers that we cannot find the LCM for the denominators very easily, right? So what we do is we take the denominator of the second number, times it by the numerator of the first number, first fraction, 33 times 10, okay? And then the second one is the denominator of the first, 59 times the numerator of the second, right? Giving us 413. So the trick says that 33 over 59, being only 330, is less than the second fraction, 7 over 10. Okay? Now if we're going to compare these next two, whether they're greater, smaller, or equal to, we take the 15 times 5. That'll give you your first number. It'll help you compare the 5/21s to the 7/15ths. So 5 times 15 is 75, correct? And 7 times 21 is 147. So which one's bigger? 7/15ths, right? Okay, go ahead and finish the next one, and I'll get on to page 97.